Well, I'm back with episode number 3 now of my introductory to photography series, back with my trusty grease pencil, and I'm going to give a pretty much comprehensive beginner synopsis of how to choose a photographic film. This will only apply to black and white film. It'll be aimed at black and white film. In general, if it applies to black and white film, it will also apply to color film within reason. There will be one big part of the video that will not apply to color film, but we'll get there when we get there. So when you're starting to use film in your photography, I highly recommend beginning with black and white film and not color film because color film has a whole bunch of other factors that you have to um, take care of before you actually, um, when you're shooting, after you're shooting, whatever. Anyway, I digress. It's just easier to use black and white film when you're beginning. Well, let's get started. Now I have all this stuff pre-written out actually to save some time. So there are two main things you want to look at when you're choosing a black and white photographic film. First is the speed. Second is the spectral sensitivity. We'll talk about the speed first because that is far more important. So what do I mean by speed? Well, this is measured in what's called nowadays either ASA or ISO. They mean exactly the same thing in the context of what we're going to be using it in. So some people call it ASA, some people call it ISO. I call it ASA. That's the little bit older way of saying it. But if you like using the word ISO, just imagine me saying ISO whenever I say ASA. Anyway, regardless, I have a few different films here. This one says 400 ASA. This one says 200. This old backing paper of Fomapan 100 that says 100 ASA. What do I mean by that? What does the ASA mean? Well, ASA is how we measure how fast a film is. The faster a film is, the more sensitive it is. So the speed of the film, the sensitivity of the film mean pretty much the same thing in this context. And by that, I mean the higher the number is on the side of the film there, the more sensitive it is in this system. So, and it's proportional. So you'll see 400 is twice as large as 200. Well, you'd be correct in thinking that this is actually twice as sensitive as this film. So this film requires half the amount of light to get a proper exposure than this 200 does. If you remember in the last video about exposure basics, it's important to get a proper exposure because if you let too much light get to the film, the image will be washed out. If you let too little light get to the film, there won't be enough information to fully form the image. So you want to kind of get the correct exposure to get a usable image. And if in doubt, always overexpose, don't underexpose, because film is far more tolerant to overexposure than underexposure. Anyway, I'm about to give you the two biggest things to look at when you're looking at film. Of course, there's a whole bunch of other factors that you want to look at, but these are the two most important generally. Anyway, these numbers are not arbitrary. They are part of a sort of set of numbers that we pick from. And they're listed here, the most common ones, 25, 50, 100, 200, 400, 800, 1600, and 3200, with some intermediate ones being 125, 160, and 250. Pretty much every film that you're going to encounter is one of these numbers, with very few exceptions. If it's an exception to this, it's usually a specialty film, and you're probably not going to encounter that as a beginner. So we're only going to look at these. In fact, for this discussion, we're only going to really look at two of the numbers, 100 and 400 ASA, because by far, those are the most popular numbers, the most popular film speeds. So representing that, I have here some Fomapan 100. You'll see 100 ASA it says there. I like that it says ASA, not ISO. And some Ilford XP2 400 here. Or if we want to be real apples to apples, some Fomapan 400. Look at that. Almost identical. Anyway, what does this mean in practice? Well, again, as you might have assumed, that 400 speed film is 4 times as fast or 4 times as sensitive as that 100 speed film, which means it's going to require 1/4 the amount of light. So, like I said in the last episode about the Sunny 16 rule, to get proper exposure for 100 ASA film on a sunny day, you set your camera to 1/100th of a second at f16. To get proper exposure for the 400 speed film, you'd want the closest to that, which on most cameras would be 1/500th of a second, at f16. You'll see the aperture remains the same, but the shutter speed is faster on the faster film. This is why having a faster film or a slower film can be useful. Now, let's take this Rolleiflex K4A as an example here. This lens can only open up to f3.5, which is basically the same as f4 in this discussion. So we'll just pretend it's f4. Let's say I want to take a photograph inside this room here that I'm in. I'm indoors, obviously. I only have some small windows. So let's set this light meter here that I have. I set that to 100 ASA. I'm going to take a light meter reading in this room. Pointing it at the wall, I'm getting an exposure of 1/15 of a second at f4. So let's set that to the camera. f4 or f3.5 pretty much. Now the lens is wide open. We cannot let any more light through the lens with the aperture. And let's set that to 1/15 of a second, or 1/10 of a second is as close as I get here. Ooh, wait, there's an issue now. 1/10 of a second is too slow to hand hold because you'll the camera shake from your hands because we're human. We can't hold the camera perfectly still. The camera shake will make the photo blurry. So that means I can do only one thing at this point if I want a handheld picture. I can't adjust the aperture because it's already wide open. The shutter speed is already too slow. I can't speed it up or else I'll be underexposed. So what's the last part of the exposure triangle? The film speed. So instead of using 100 speed film, let's see that with 400 speed film. We take the same reading here. Ooh, would you look at that? That says now 1/60th at f4. Curious. Double check. Yep, 60 at f4. On this camera, the closest to that would be 1/50th of a second, which they're practically the same for this purpose. And would you look at that now? I'm wide open, and the shutter speed is now fast enough that I can hand hold this camera to take the photograph. So you'll see it's useful to have a faster film when in darker conditions because it allows you to actually hand hold images, or you can use a narrower aperture so you can get a wider depth of field. It's more practical, and usually shooting wide open on lenses is when the lens is at its worst performance. It'll be, a lot softer of an image. Or if we want to go to the extremes now, some conditions, if you have a faster film, you'll be able to get an image in the first place. Because if you have some of these slower films, like 25 or 50, some cameras cannot open wide enough or go slow enough to even get an image at all on the film indoors. So something like 400 to 3200 speed film is good for indoors because, 3200 speed film, you can get an image by candlelight. So it's useful to have these faster films for lower lighting conditions. But wait a second. Why don't we always use fast films then? If, it allows you to get more images in more difficult conditions. Well, there's a big drawback. You see, to increase the speed of the film, one of the things that's done is the grain size of the emulsion is increased. And that means that the image produced by a faster film will be noticeably grainier than that of a slower film. So to get a higher resolution, a higher sharpness image, you want to use a slower film. That's why a lot of landscape photographers or whatever will use these slower 25, 50, even 100 speed films to get a finer grain, a higher resolution, much sharper image, because they can afford it. Generally speaking, for a given set of conditions, you want to use the slowest film that is practical. That also allows you to use a slower shutter speed outdoors if you want to get some motion effects if you stop down. But the reverse is true. If you're outdoors, let's say at a soccer game, and they're kicking the ball around at very fast speeds, you want, let's say, a 500th of a second to freeze the action of that ball because it's going around pretty fast. If you have 100 speed film, and let's say it's overcast, like it's a dark overcast day, you're at 1/100th of a second at f5.6. And let's say the telephoto you're using can only open up to f5.6. Some can only open up to f5.6. Well, that 100th of a second is not going to be fast enough to freeze the action. The ball is going to be a smear. So let's put some 400 speed film in that camera. All of a sudden, let's bump it up 2 stops. 1/500th of a second, 1/500th of a second at f5.6. Now you have perfect exposure. So again, you want to use faster films if you want a wider depth of field, or you're trying to capture action, or there's just low light. You want to use slower films if you want higher resolution, sharper image, and you want to use a wider aperture, try and get selective focus, or a long exposure. Generally speaking, you want to choose 150 speed films, 100 speed or 50 speed, I should say, films if you're outdoors on nice conditions. 400 and 800 if you're outdoors in really bad conditions or indoors. And 200 speed films if it's kind of dark outdoors or it's kind of brighter indoors. This is just a general guide. It's not a hard and fast rule, but if all else is equal and you're just like, what kind of speed film do I use? That's a general good guide. So the next thing, and this is a bit more theoretical now, but still important nonetheless, is the spectral sensitivity of the film. I have a good example of this right here. VP620. Well, we can see on the bottom there, it says Verichrome Pan 620. Pan, what does that mean? Well, pan means panchromatic. That comes from the Greek words pan here, which mean all-encompassing, and chromatic, meaning colors. Panchromatic film is sensitive to all colors. If we look here, this is my interpretation here of the visible light spectrum. We have all your rainbow colors, and then we have UV light and infrared light, but I shaded those in because you can't really see those, so we'll ignore those for now. Panchromatic film, you'll see, is sensitive to all these colors. Meaning, if I point the camera at like a rainbow like this, all these individual colors will be shown, represented in their true gray values. That's good. That means you're going to get nice even tonality, and things like this here, like this red here, will show up as like a middle gray kind of. So will this yellow and this black. Or lighter colors, like let's say this sealing wax I have here, this green, will show up as a gray as well. That's good. That's good. Let's say to the extreme now, I have this blue eraser. What will that show up as? Well, we can see here, blue, that shows up as a gray as well. That's good. Moving on, we have some generally older type films. They're still sold though. They're kind of specialty now, but if you want some interesting creative effects to your photographs, you can actually choose these films and get some cool effects. Now, I'm going to skip this middle one for now and go straight to this one here. You'll see it's labeled BS for blue sensitive. Now, that sounds exactly what it is. Blue sensitive. It is sensitive to blue. Notice I have it here. It's blue to violet and ultraviolet. Generally speaking, all films are sensitive to ultraviolet, so just take it for granted that your film is going to have an ultraviolet sensitivity. Which, incidentally, is part of the reason why it's easier to take photographs outdoors than indoors, because you have all that extra ultraviolet light. Anyway, blue sensitive emulsion is the first type. When we first discovered how to make emulsions, the silver chlorides that we used were only sensitive to blue light, blue and ultraviolet light. So if you took a photo of this, let's say, that shows up as nearly white. And let's say I took a picture of this film roll here. Well, the red and yellow here are, notice, far away. These are warm colors. They'll show up as black as that black band right there. Same thing with like this this orange battery. This would show up black, not gray, as in what the panchromatic would give us. Now, it'll create an image, all right. That'll be fine for, just getting a photograph of something. And that's all we knew how to do back then. But some people discovered that if you add some dyes to the emulsion, you can actually increase its spectral sensitivity. So around the late 19th century and used throughout the 20th century up until about the 1940s or 50s so regularly, we had what's called orthochromatic emulsion. Ortho, from the Greek word meaning straight or true, and chromatic, again, meaning color. So true color. This is sensitive to both blue and green. You'll see this has an extended sensitivity. That's good. Now, if I show, again, that sealing wax, this will be sort of, it won't be, absolutely true color as represented in the panchromatic, but it'll be far closer. It'll be a sort of, it'll be a pretty good, a fair gray. Likewise, this blue will be represented more of a gray, less as a white, but still, this will be represented as almost black. That red will probably be black, actually. But wait a second, I said true color. Well, here's the thing. That's kind of a misnomer nowadays. Orthochromatic, that term, was coined in the 19th century. And remember, they were used to using this blue sensitive emulsion. All of a sudden you have green and just a little bit of yellow. Wow, that's practically true colors to these people back then. So they called it true color, orthochromatic. Nowadays, if you buy an orthochromatic film, you're buying it to have that orthochromatic effect, to have that the blues be lightened and the reds be darkened, that kind of effect to it. Again, it was an important step, but kind of not as good as panchromatic. And then panchromatic film, they added extra dyes to it to fully extend that sensitivity to the red. So now, again, panchromatic is sensitive to all colors. You'll notice that if this is a fixed amount of light, which it is, let's say outdoors, as you are sensitive to less wavelengths, you're accessing less of that light. You're using less of that light. So, as you could correctly imagine, a blue sensitive emulsion will be a lot slower than a panchromatic emulsion. All these fast films here, like 3200, 1600, down to, yeah, around 200 or so, are going to be panchromatic emulsions because you need access to all that light to get a film that fast. Orthochromatic emulsions are pretty much at fastest 100, and they go down further than that. But like commercially available, I believe the slowest ones you can get are around 6 or so ASA, around there. And the blue sensitive, you will really struggle to find any blue sensitive emulsion that is faster than 25. Usually they're around ASA 1 or so, or maybe even into the fractions, just simply because you're using less of that light. Now, there is one other line here that I drew. IR. Well, of course, that stands for infrared. You'll see panchromatic is not sensitive to that, although some are, like Fomapan 400 here, has some sensitivity to infrared. But there are some films that are purposefully made to be sensitive to this infrared region. It's sensitive all the way from UV through the color and then up to the infrared region. And this can be cool. This is purely, in the art world, this is purely done for its aesthetic effect. They were originally made for the military so they can image forests during wartime and see where enemy encampments are. But nowadays, we use them because they have some interesting effects on natural subjects. If you put a filter in front of your lens that only allows UV light, IR light through, infrared light through, you can actually get some really stark, contrasty results with it. The sky, which is blue, turns jet black, and foliage, like trees and bushes and grass and stuff, turns snow white, and you get this really surreal look to it. If you don't really use a filter, an IR filter, it pretty much just looks like a panchromatic film. So if you want that infrared kind of effect, you really want to put one of those filters in front of it. So yeah, that's the two most important things to take into account when choosing a film. The last thing I will mention is, when you're buying a film, make sure that it's the correct format of film for your camera. That's probably, that is very important. There are several different formats you can use. Like the most common that you'll find is 35mm, which uses cassettes like these. This format here, with the 35mm inside this type of cassette, that's called 135. You'll notice it says 135 on the side there. You would load that in the camera by, of course, stringing it over there. They usually have a take-up spool. Basically, if your camera looks remotely similar to this, it takes 135. The next most common is 120. That comes on spools like this or like this. You'll see they're kind of fat, and they have this paper backing to it. So if your camera, like this is a TLR, for example, not all 120 cameras look like this, just like not all 35mm cameras look like the one I just showed you. Like here's a Leica, that looks kind of different. But generally speaking, if it has these plastic spools in it, like you see there's a plastic spool in there, and there's like no spool here, well, that means it's likely going to be for roll film. Like you load it in here. This is just a practice roll. It's an empty roll. That's why I can do this in the light here, to show you. See, there's no film in there. But you thread that on here, and you whoop, up, up, up. This is a roll flex. You have to pass it through the rolls. There we go. And once I wind that on, there we go. And then you'd close the camera at that point. But you see how there's this backing paper or whatever? That's called 120 film. Be careful though, because there are some cameras, particularly older cameras, that use what look to be 120. It looks like this. However, it's not actually 120. That's what this is. This is 620. Again, this is just an empty roll that I have with just the backing paper. This is the exact same film as 120. It's just on a different spool. You'll see the keys are different, and it's a lot thinner, the ends, and the interior spool is a lot slimmer than that of 120. So generally speaking, if you have a 620 camera, it will yell at you a million times on the inside of the film compartment, use 620 film. 620 film is no longer produced in large quantities. What you have to do is you have to find some of these 620 spools, and in complete darkness, unspool from the 120 spool and spool it back on the 620 spool. I'll probably have a video on that in the future. But yeah, if you're really new to this, just skip on the 620 cameras. They're kind of fiddly to use as a beginner. And then the third popular like format of film is called sheet film. I have a sheet film holder here. This is a 4x5 holder. That's 4 by 5 inches. And this would go into a large format camera, and there's sheets of film in here. I'm not going to open this because this one actually has film in it right now. And these are exactly what they sound like. They're sheets of film. You'd open this in a dark room, slide a sheet of film in there, close it back up, and then when you're ready to shoot, you put that in the camera. You pull a dark slide, which exposes this to the inside of the camera. The camera shutter goes off, it exposes that, and whatever. If you're a beginner, I really doubt you're going to be using these. So for now, you can pretty much just ignore the fact that these exist and concentrate most of your energy and thought onto 135. This is probably going to be your best bet. But yeah, 135 and 120 are pretty easy to use. But at this point, I'm just going on a tangent. That should be all that you'd need to know to get started, enough to get you into trouble. If you have any questions or comments, please put them below. And thank you. See you in the next episode.